please pay attention. The topic one, maybe topic one talk about inflation. Maybe one of the the vocabulary that has a huge weight is actually inflation. Okay, inflation. Another one, um, maybe I want to talk about markets, and I want to talk about. So I talk about inflation. I talk about markets. Okay, I talk about markets. Okay, I'm talking about vocabularies that are actually clustered within a topic. Okay, maybe I talk about jobs. I talk about jobs. Okay, okay. So I talk about inflation. I talk about market. I talk about jobs. Maybe I talk about unemployment rate and so on like that. Of course, I can actually give a befitting topic for that. Okay, probably they're talking about economy. Okay, this is what this is talking about. Maybe another I'm talking about this guy now that I call the cluster of words by topic. Maybe topic two, maybe talk topic two, okay, topic two, okay, may have something to do with coach. Okay, maybe we have some vocabulary, some unique word like coach, like game, okay, like game, okay, like go, and so on like that, then I'm actually going to know that topic is likely going to be sports. Does that make sense? So this is what I mean by clusters of word by topic. Now, another thing that I actually want to talk about is this: the cluster of documents by topic. When I say cluster of document by topic, maybe in document one, please pay attention. Maybe in document one, okay, I'm actually having maybe document one is about 70%, okay, 70% of topic one. Okay, when you are reading through a newspaper, maybe on the front page, maybe on a particular page, it could be about 70% or maybe of economy stock, and maybe 30% about sports. That's exactly what I'm trying to say. So maybe document one is about 70% of topic one and 30% of topic two and 30%, okay, of topic two. And when you look into another document, maybe document two, maybe 90% of topic two, okay, 90% of topic two, and maybe 10% of topic five. That is what I mean. So which means within document, okay, we actually going to give the distribution of topic. Distribution of topic. When I say distribution of topic, you are trying to say the frequency of topic within a document. Okay, so what the topic model is going to do, like I said, okay, when you have and the connection of topics of documents. Give me 1 second. When you have the connection of document, okay, so when you have the collection of document, the topic model is actually going to split that into two, into the cluster of word by topic and the cluster of document by topic. By cluster of document by topic, okay, I want to look into combination of topic and of document, and I really want to know what they are thinking about. Thinking about in terms of topic. That is exactly what I mean. Now, let me tell you this. If I now want to analyze this statistically, or I want to use machine learning algorithm, okay, I actually need an input, okay, and don't forget, I need a numerical values, okay. I want to formulate a matrix. Please, I need you to pay attention on how this matrix can be formulated, The moment we're able to formulate a matrix, of course, it will be very, very easy moving forward. Don't forget, all this is why we've been working on matrix, covariance matrix, data matrix, that matrix, and so on like that. If we are able to generate a matrix from here, of course, the approach that I identify can actually be used. Now, this is what we're going to do. Okay, we actually the matrix. If I have n documents, okay, I have n numbers of documents. Maybe I have thousands of documents. Okay, I'm now going to convert the thousands of documents into document term matrix. Document term matrix is what we call DTM. What do I mean by that? In column, okay, when you take a look at, I'm going to have something in column, I'm going to have something in row. Now, in each row, I'm going to have documents, document 1, document 2, document 3. In each column, I'm actually going to put vocabularies, words. Do you know what I'm going to have in each cell? The number of time a particular word appears in a particular document. With that, we are now going numeric. Can you see that? I'm going to say that again. What this guy is trying to say here is that, I'm actually want to convert my end document. When I have end document, okay, in on a row, I'm actually going to have the document in a row, occupying a row. On a column, the vocabulary that I've identified, the words that I can identify, I'm actually going to put them in a column. Then in each cell, okay, it's going to be a count. How many times does this word appears in this particular document? Does that make sense? And that is how we're going to, figure out what, the elements, the values in each cell. But let me tell you this. I said something here. Can you see that? I said Sij is how many times word J appears in document I. That is what Sij. The Sij is going to be the element in a particular cell. And let me tell you this. Uh, there are some words that we are not going to count. That we're not going to count at all. Okay. We actually going to remove them. Okay. Like the word like THE, D. It doesn't really say anything. Is. We don't want that. AND. Those are not unique vocabulary. Does that make sense? That those ones are not going to be counted. And we're going to remove punctuations mark, like a comma, period, all of that. We don't need them. Does that make sense? Okay, now in the pre-processing stage, we're going to make sure we get rid of some words that are not relevant. Okay, and that was why I said no. And another thing I'm going to say is this, if you take a look at the last one, I said note that the DTM does not keep the original order of the word. What do I mean? Let's say in a statement in a document read, the dog chased the cat. Okay, so DTM is going to treat that the same as the cat chased the dog. The order doesn't matter. It doesn't take into consideration the order. I'm going to say that again. Maybe there's a statement that read the dog chased the cat. Okay, the DTM is going to treat that the same way as the cat chased the dog. And that's what I mean. Note that the DTM does not keep the original order of words. Now, I wanted to pay attention now. We want to go statistical. So for us to be able to go statistical, we need numbers, right? We need numbers. We need numeric to go statistical. And if I have a oh my God, look at this. I got, different, so many combination of documents. Okay. We got so many combination of document. Okay. And you know what we're trying to do? We actually want to generate a matrix. Take a look at that. Okay. Now, if you take a look at what I have here now, I put document 1. I'm just assuming that here I have 5 documents. Can you see them? 1, 2, 3, 4, 5. Okay, and that is represented here. D1, D2, D3, D4, D5. And maybe in this document, I've looked into that. I've identified some key important vocabulary like complexity, algorithm, entropy. traffic and network. And do you know what the meaning of this guy? It means, oh, the how many times can I count complexity in document one? 2 times. That's why I put two. Okay, here complexity does not appear in document two. That's why you're not seeing any value. Okay, now do you understand this? Do you understand this now? Do you understand that matrix now? Now the question now, where we do not have entry, okay, am I going to leave it that way, or I'm going to put something? We are not going to leave it that way because the topic modules require that you should have a complete matrix. So what we're going to do, we're going to put zeros. Does that make sense? There is no room for not available. There's no room for missing observation here. Okay, whichever one that is missing, it means that particular vocabulary or word doesn't appear, and we're going to plug in zero. Does that make sense? Or into the missing cell. Okay, now, but the question is, how do you know that at times we don't just count the number and just plug this in like that? There's a formula that we normally use to compute those values, those entries, and I need you to pay attention now. Is everyone still hearing me clearly? Okay, thank you so much. Now, I need you to pay attention to this. There's something that we call TF-IDF. The TF-IDF is actually called time frequency inverse document frequency. Okay, we want to create a formula for that. I said sometimes people feel that DTM will not incorporate the word relative or relative rows in a corpus. At times the DTM could miss some important vocabulary, okay? Because at times, depending on the topic module you are using, what this particular topic module may see as important vocabulary may not be what the other module is going to see as important vocabulary. And because of that, we normally want to correct, we normally want to have a way, to figure that out. And I said, the time frequency inverse document frequency is a numerical statistic that help, okay, it puts higher weight on more informative words. Let me tell you this. If some vocabulary are more informative, they're going to be assigned higher weights. If some word, maybe they are less informative, they're actually going to get lower rates. Lower weight. Does that make sense? And I'm going to give you an example now. If a document one contains the word apple 3 times, apple, maybe I found apple 3 times in document one, okay, and the word apple appears in 2 out of 5 documents on a corpus. Let's say you have 5 documents, apple only appear in 2 of the documents, but in one document, in document one, it appeared 3 times. Now, in this situation now, we need the formula, the TF-IDF formula. Now, please pay attention, okay? The TF-IDF formula is actually this guy here. It's going to be the frequency of apple in document one. What is the frequency of apple in document one? 3, right? We're told document one contain the word apple 3 times. Multiply by the log. I'm going to multiply that by the log. The logarithm of what? The total number of documents that we have. Oh, the total number of documents that we have is 5 divided by the number of documents containing apple. Take a look at that. Now I need to compute this mathematically. You can use your calculator. Okay. Now using this guy now, okay, that will determine the value that you're going to assign. So what does that mean? Okay, I'm actually saying, can somebody get that for me? What is the logarithm of 2 point, because 5 over 3 is 2.5. Multiply 3 by log of 5 over 2. Can somebody give me the result? Okay, why you are giving me that? That apple is more frequently in document 1, but it is very rare in the entire number of documents. Go ahead. Thank you so much. 1.04. So now, that is what I'm actually gonna reckon with. Let me tell you once again, okay? The TF, IDF, more when you use this approach, more informative, informative, the particular word that is more informative is actually going to be assigned a very huge weight. I actually want to move right now. Please pay attention. Now, text. Now, we are now seeing text data as a multivariate data. Multivariate data in the sense that, of course, we have so many documents, and the word will be the number of observation, and that's a multivariate. We can apply the approach of PCA, principal component analysis, because we want to have a dimensionality reduction. Don't forget, in the principal component analysis, we normally create an artificial variable. That's a linear combination of the old features. And of course, here we can also do the same in the text data analysis, where we actually want to reduce the dimensionality in the text data into fewer numbers of topics. And don't forget, each topic is actually going to be a linear combination of words. Okay, so the MDS can also be used. Okay, the multidimensional scaling that we've done before. Don't forget, both principal component analysis and the multidimensional scaling, of course, they can actually help in the data dimensionality reduction technique. And of course, let me tell you this. The moment we're able to, reduce the dimension, okay, of course, that will actually translate into what we call better accuracies and interpretability. That's what I mean. Now, I want to move right now. I want to talk about basic structural assumption for topic models. Every statistical model has assumptions, okay, including the topic model. And you know what? If you really want to, uh, be certain about, the validity of your model, if you want to know whether your model is doing a great job, of course, the assumptions underlying the use of the model has to be met. Now, what are the assumptions of topic models? Number one, each document consists of a mixture of topic in a certain sense. So we believe each document is a mixture of topic. Of course, when you see document, okay, a document has several topics in it, okay, except that you're actually going to have different proportion, different distribution, okay, of topics in document. And not only that, each topic, if each document is a mixture of topics, then each topic too is a mixture of words. Each topic is a mixture of vocabulary. So that's why I say each topic consists of collection of words, okay, in a certain sense. Okay. Now, there's something that we call the back of word assumption. I said, from the modeling perspective, the order of word does not matter. I told you the other time, the order of word does not matter. I said if the dog chase the cat, okay, it's going to see it the same way as the cat chased the dog. So the order doesn't really matter. Okay, I want to walk you through different types of topic models that we can have. The moment if I ever succeeded in converting my text data into numerical data that we're going to have in form of a matrix, in form of a matrix, you actually are going to have documents in row, and you're going to have vocabulary in columns, or it could be the other way around. Then I should be ready to use what I call latent semantic analysis. Latent semantic analysis is one of the topic models that we have. Now, how does it work? Okay, this is deterministic. This is not probabilistic. Okay, this use PCA approach, but PCA with a singular value decomposition. Okay, you know, this is a very basic idea. Like I said, it does not really make a lot of sense. Okay, but take a look at this. Um, you know, we're actually going to use the idea of principal component. You remember, since I have a matrix, please pay attention. Since I have a matrix, I can do singular value decomposition. We're going to rely on the approach that we've learned before in this class that I call matrix factorization. Of course, you know, that's a way of splitting matrix into two or more pieces. Of course, but we want to use principal component analysis with a singular value decomposition. If it means our TF IDF matrix Y is actually going to be decomposed into three components. Take a look at the component now, okay, into U, D, and the transpose of V. Okay, now we actually going to use rank. Don't forget, with a singular value decomposition, we are not going to use all the rank. We're going to use a less full rank. Okay, now at the end of the day, what we're going to do, we're going to truncate. What is the meaning of U? What is the meaning of D here? Okay, please pay attention. The U, like I said, if you take a look at this, I said each row of matrix U here is a vector representation corresponding to documents. Okay, while each row of V, okay, is a vector representation corresponding to word. Can you see that? And YD is actually going to be the diagonal. You remember the way the diagonal now is where you're now going to have the singular values, where you are not going to use all the singular value. You're actually going to use the top singular value. So the semantic approach of analyzing text data is deterministic and it rely on matrix algebra. It's not statistic. It's not statistical. Okay. So this actually use idea of a singular value decomposition. Okay. So since we have done that before, we're actually going to benefit from that. Now, uh, you know, like I said the LSA is essentially an embedding method. The interpretation is very vague and artificial because it's actually it's we're using the idea of a matrix algebra. This is now there's nothing statistical here, and because of that, I said it does not really take any special properties of test data into consideration. Okay, so that is the weakness of this approach. Okay, now the next approach and another thing, another weakness of this approach, there is possibility that the count uh, in the number of words, there's possibility that we're going to have negative. Don't forget, when we're working with the principal component analysis the other time, when you look at the eigenvectors, some could be negative, some could be positive. But in terms of counts, we are counting word. We don't want negative count. Instead that you have zero count or you have a positive count, and to be able to improve on that, we are moving into what we call another method that we have used before in this class for matrix factorization that we call non-negative matrix factorization. Why are we using non-negative in topic modeling is because of the fact that we don't want to tolerate negative numbers. Does that make sense? Now, I want to show you how it's going to work. Your X, please pay attention. Okay. Your X, actually, you have a lot of document. Can you see document? Okay. The document is actually what I'm referring to dictionary here. Okay. The document is, so you can see each bar represent that. Now, I want to partition this into two, into W and H. What is W? Please pay attention. The W, this guy is a set of words that we found simultaneously in different texts. I'm going to say that again. The set of words that you find simultaneously in different texts. And this guy is going to be the weight. That weight is what you're going to use to reconstruct. Don't forget, if I multiply W by H, it's not going to give me S because we actually want to truncate. Every module is going to give us an approximate idea. So here we have been, the non-negative matrix of factorization, we ensure the element within the W and the element within the H, they're going to stay positive. Does that make sense? But this is still approach of matrix algebra, except that it's a little bit better than principal component analysis with singular value decomposition. Now, I said about the NMF, okay, I said directly apply to the DTM. Okay, when I say DTM, document time matrix, and the non-negativity is used. And I say each document, of course, is a mixture of multiple topics. And I say each topic is associated with a word of different weight and much more meaningful than LSA. So what I'm trying to tell you now is that this approach is more, it's actually more meaningful than the latent semantic analysis approach that we used the other time, the approach that actually use a principal component via singular value decomposition. Okay, now now when you take a look at these two methods, the LSA and the LMF, they are matrix algebra approach. There's nothing statistical about them. We now want to go to something statistical. Okay, to go to something statistical is to consider what we call latent Dirichlet allocation. Okay, this guy, we put into consideration the frequency, okay, the word frequency from set of document, and of course, we're actually going to use the idea of probability distribution. Let me tell you this in a stochastic world. If you really want to efficiently measure, having an understanding of what happens in a stochastic environment, we normally use probability distribution. So in a latent Dirichlet allocation, that is statistical because that incorporates probability distribution. Look at what I said. I said the ADA is particularly useful for finding reasonable accurate mixtures of topics because with LSA, with NMF, you may not be able to have accurate mixture. The document may not be accurate mixture of topic because that is going to assume it's going to say it's linearly separable. What if in a situation where it is not linearly separable? And how are they going to get the right mixture of topic, like in terms of percentage? And the appropriate way of seeking redress is to go probabilistic, which is going to bring in probability distribution. Okay. Now let me tell you this. With this, I can actually find what is the probability of word given topic. The idea of conditional probability can actually be used. What is the probability? What is the probability, okay, of observing a word, okay, given a particular topic? Okay, you know what this guy is trying to say? Given a particular topic, I can figure out the proportion of words. I can figure out the frequency of word. And not only that, given a particular document, I can also find the probability of topic. Okay, the probability of topic can also be found, okay, given a particular document. Take a look at that. Okay, we're not able to answer any probabilistic query using the other method that are matrix or the linear algebra base. We're not able to do this, but with latent Dirichlet allocation, we can answer probabilistic queries. Okay, that's exactly what I mean. So, and of course, the goal is actually to infer, the hidden topic, that will best explain the observed frequency of word. Okay, I'm going to say that again. We want to have a way to infer the hidden topic, okay, that will explain, different observed word frequencies. Now, how do we use ADA? To use IDA, of course, we have to convert the document to its atomic element. Don't forget, we need to have it in in a matrix form. We have to remove some meaningless words like is and so on like that. And we need to match words. Okay, I think I forget to mention that under this approach, if you want to, like, if you have one second. If you have a word like run, a word like run, run, running, or runs, they can be classified as just run. What I mean is, if I say in document, maybe run, this imply running. Okay, this imply runs. I can just use run for that. Okay, that's what we mean by merging words that are equivalent in meaning. You are not going to count them twice. Okay, this doesn't mean I have one, two, three, four. No, it's just one. That's what I mean. Okay, now let me quickly run you through example. Okay, if I want to find out the news highlight of France in 2018, of course, in the France hosted 2018 FIFA World Cup, and I'm giving data set which contain all the news articles of the country from 2018. News article, not only sport. Maybe you have access to article from France, okay, in 2018, okay. And what you want to do, you want to use the LDA to find out the topics, what the topic is going to be, okay. Now, the example, in 2018, to the best of my knowledge, France won 2018 World Cup. I think they play against Croatia in the final. Is anybody here that normally follow soccer, like a world soccer? Okay, so France won that. Now take a look at this. If I want to find three major topics from the document that I've collected, okay, now we have three times football was mentioned in document, two times World Cup was mentioned, one time 2018 was mentioned, three-time winners was mentioned, and that if I want to talk about the document high now, I'm actually saying that I have topic one is going to base on two, topic two is going to base on one, and topic three is going to base on two. So why am I actually saying that? Okay, you can see here, you can see two, you can see one here, one here. Okay, okay. So if you take a look at topic one, how many do we have under topic one? Two. Can you see that? How many do you have under topic two? You only see World Cup. Okay, I'm going to say one. How many do I have under topic three? I saw football and winners. I'm actually going to put that. Look at that. Okay. Now, if I now want to consider World Cup only, okay, this is what I have. Okay, if I want to consider, I want to reassign the topic for the given word. Okay, okay, I actually want to count. If you take a look at this, you can see. So now this is actually giving you, okay, how we can relate topic with documents. How many topic do I find out in a particular document? If you take a look at what I'm showcasing now, topic two is now found in document high, but we found topic one twice. We find topic three twice. That's exactly what we mean. Now take a look at this. If you take a look at what this is displaying, topic one actually load more on, if you take a look at this, uh 2018 France, okay. If you see that, if you see more load on that, 2018 and France. And France hosted World Cup in 2018. And if you look at the World Cup, can you see that? And topic two, load more on World Cup, because look at the eight. Topic three, load more on football and winners. Topic three, load more on football and winners. You can see what I'm having now. So please pay attention, okay, on that. Okay, so there's another one. If you take a look at what I'm having now, if I want to talk about dynamics, okay. So now what we're going to do next, I'm actually going to walk you through the PLSA. And let me tell you this, the good news is we have how we can do this in R with a code. If you want to compare all the method, okay, we have how to do that in R. What we're going to do next, we want to go more probabilistic, okay, that we're going to call, we want to introduce probabilistic approach to LSA. Initially the LSA that actually use idea of matrix algebra. Can we also introduce probabilistic approach to LSA so that we can compare with the LDA? LDA is already probabilistic. all of this can be done in hour. Before I go, if there is any group here who actually want to switch their topic, or maybe they want to change their topic, sorry, the area, maybe they want to change the area for this, for topic module, or for a portfolio theory. I did not assign anybody to portfolio theory because portfolio theory and topic model, because we're doing it lately. But if you are still fine with what you have, keep working. Okay, we're not meeting on Wednesday in person. You have to join the Zoom, and on Friday you don't join the Zoom. I'm only going to record the lecture for Friday, which is going to be the last lecture of the semester. So while you are away for Thanksgiving, make sure you stay safe. Okay, that's all what I got. Bye for now, everyone. You're welcome. Yep.
Hi, so my group is a bit confused about exactly what we're making from this solution. So obviously we're doing some ours is factor analysis, so the factor analysis and R, turn that into a 10-15 presentation. Are we also making a
No, it's not 10-15. No, it's not 10-15. If you look at what I put in the announcement, the number of pages 10 to 15 is for final submission. After the presentation, yeah.
Okay, so
after the
a
presentation.
presentation and separately it's
Exactly. Exactly.
Okay.
Exactly. No? Or the one more. Because we already have a group assignment, you're working on.
True. So after the last lecture on Friday is only gonna, so we're only gonna be focusing on the presentation until
exactly.
the final.
So the
exam.
final, exactly. So the final lecture is Friday. So the other week, the next week is gonna be for presentation. So what you need now is be focusing on presentation and the final.
Okay. Are you gonna upload like a practice final exam?
Yeah, I will.
Okay.
Just like the same way I did for the
Okay.
meeting. Yeah,
Sounds good. Thank you.
you're welcome.